Okay, so in this lecture, we will be using recursion to create a power function. So what exactly is a power function? Let's take a look. So if I say 2 to the power of 3, what basically I'm saying is that 2 multiplied by 2 multiplied by 2, which is, well, 8. So 2 to the power of 3 is 8. And that is what we're going to do with recursion. We are going to allow the user to pass in the number and to pass in the times the power, and using that we are going to calculate, you're going to use recursion to calculate the power. All right, so let's go ahead and do that. I'm going to go ahead and create a function called power. We are going to pass in the number, which is integer, and to the power, so I'm just going to call it POW, or I would say maybe 2 or times is okay, I guess, or let's just call it n, all right, just for simplicity's sake. And it is going to return you an integer, all right. So for the number, we're going to pass in 2, and n will be, well, this many times. 2 to the power of 3 will be 8, just as we're returning over here. So now we're going to check if n is actually equals to 0, then we will go ahead and return 1. That's the first thing. So this is our base case for the recursion. This is the one that is going to end our recursion. Next up is the recursive case. So else, we are going to simply say return the number that we have passed, multiply by, and find the power. So this is the recursive call that we are making to the power function that we implemented, or we are implementing, and we are going to pass in the number, and we are going to pass in the n minus 1. All right, so let's go ahead and see what happens now if we call power. So power 2 comma, well, let's go ahead and do that, 2, and then we're going to pass in 3 and go ahead and print out the result of what is going on. It has to be 8, and you can see it's actually 8, and this is how we have written the power function, which uses recursion to basically calculate the power. Now let's see what happens behind the scenes. So if we have a stack, remember that we learned about the stack when you're using recursion. Let's see what happens when the stack is created. So we're passing 2 and we're passing 3. Is 2 or is 3 equals to 0? No, it's not. We are going to return this. What is this? The number. The number goes into the stack, multiply by power, and what do we pass in the power? We pass in the number, which is 2, and we pass in the number minus 1. So this was 3, so 3 minus 1, that is 2. So now we pass in over here the number, which is same, which is 2, but the n that we're passing, the times, is also 2. Is n is equal to 0? No, it's not. It's actually 2. So number 2 multiply by power of 2, and then we pass in 1. And the same process goes again. Is 1 equal to 0? No, it's not. Then you pass in again 2 multiplied by power and 2 to the power of 0. Finally, we pass in 0. This case is going to met. It's going to return 1. This means that power of 2 to the 0 is actually 1. This gets evaluated. So this is now 2 multiplied by 1, or 2 to the power of 1 is 2. So we replace it over here. This goes away. And finally, we replace 2 multiplied by 2 with the power of 2, which is 4. And finally, we come up to be 4 multiplied by 2 is equals to 8, which is the power of 2 to the power of 3. So using recursion, this is how we have calculated the power.